Chapter 7. Today we're going to talk about integer exponents. Up until this point we've dealt with whole number exponents, like the example that they have here with 3 to the second power. We know that basically when we have something to the second power, we're going to take that as a factor twice. And 3 to the second means 3 times 3, which gives us 9. And today we're going to talk about what it means for an exponent to be 0 or negative. And in the next couple lessons here, I'll be able to prove this a little bit differently. But as for today, we're going to look for a pattern, and we're going to use powers of 5 here to do that. So as we go down the line, we'll look for a pattern here. But let's start with something that we're familiar with, like 5 to the first power. 5 to the first power is 5. 5 to the second power is 5 times 5, which is 25. And as we go up, we get these numbers. So the pattern that we would see here is if we move from left to right now, we get this pattern where we're dividing by 5 each time. So 3,125 divided by 5 gives me 625. And then 625 divided by 5 gives me 125, and so forth. So we keep dividing by 5. So if we do that then, and as we go down from 5, 4, 3, 2, 1, 0, if I do 5 divided by 5, I get 1. Alright? And then if I continue this and I go down to negative 1, I go 1 divided by 5, well that's 1/5. And if I do this one more time, 1/5 divided by 5, that's like 1/5 divided by 5 over 1, or 1/5 times 1 over 5, right? Or 1/25. Okay, so we don't actually get negative numbers when we have something to a negative exponent. We still get a positive number, but we get a smaller number. Okay, we get a decimal. So there is a rule here, and anything to the 0 power, except for 0, will be 1, no matter what. And like I said, I will prove that differently in the next couple lessons here. And anything that's to a negative exponent is basically, I like to think of as like an inverse type property. So for instance, if I have x to the negative second power, let's say, I can just say, okay, that's going to be 1 over x to the second. Because if I go back and I look at 5 to the negative first power, we got 1/5, which is the same as 1 over 5 to the positive 1. And if you look at 5 to the negative second, that's 1 over 5 to the second. So basically what you do is you take, I like to put that over 1 and then move it to the bottom, and that will turn this positive. And that's how I go about that. So let's take a look at some examples here. Alright, so if we simplify these, 2 to the negative third, using our rule, is the same thing as 1 over 2 to the third, which is 1. 2 times 2 times 2, which is 8. So we get 1/8. 5 to the 0 is 1. Anything to the 0 is 1. Negative 3 in parentheses to the negative fourth. That's the same thing as 1 over negative 3 to the positive fourth. So we'd have to take negative 3 times negative 3 times negative 3 times negative 3. We're multiplying a negative an even amount of times. We end up getting a positive, and it's 1 over 81. The difference between C and D is that we would say, okay, negative 1 over 3 to the fourth. So this one we get negative 1 over 81, and go like that, okay? Because the negative is not in the parentheses like it was in C. Alright, we've got somewhere we can do some evaluation type things. So for instance, if we have x to the negative 1 and we substitute 2 in there, this is really like 2 to the negative 1, which is 1 over 2 to the positive 1 or 1/2. Secondly, you can already look at this like, okay, well I know anything to the 0 power is 1 no matter what I put in for a. So this is just like 1 times b to the negative third. Well, b is negative 2. Or this is the same thing as negative 2 to the negative third. So I could just say 1 over negative 2 to the third. And negative 2 times negative 2 is positive 4, times another negative 2 is negative 8. So we get negative 1/8 for that. Alright, and lastly, what happens if we have an expression with a negative exponent in the denominator? Well, we're going to use the rule to see what would happen here. If I put negative 8 in, so they're just taking this rule and flipping the equality. It's the reflexive property, just switching the directions here. If I put negative 8 in for n, using the rule, a negative becomes a positive. So really what happens here is this is the same thing as x over 8, or x to the 8th power positive. So what I like to think of is if I've got something in my fraction that's got a negative exponent, I consider that not happy. So I'm going to move this to the other spot to make it happy. X over 8 to the first, or just x to the 8th power. Alright, we'll talk more about that tomorrow.